So we're trying to simulate an experiment for you, and we're looking at how does earth material or how does sunlight impact earth material temperature. And so we have two similar containers, one filled with water and the other with soil.
Now you may be wondering, why did we pick these two particular materials? Well, earth material, that's any non-living substance that's on earth, and the earth is made up of a couple of different parts. We talked about the atmosphere in our earlier studies. So you have the layer of gases that are around it, but then you also have the geosphere, which is made up of like soil and rocks and different things. So we have our geosphere, and then the other part of the earth, or the other sphere that makes up the earth, is the hydrosphere, and that is all of the water on Earth's surface. So that's why we chose soil and water. And we're going to see the effect, like Mrs. Harrington said, the effect of sunlight on these earth materials.
So we're going to be recording in your notebook the starting temperature at time 0, and these thermometers are not calibrated exactly the same. So we're looking at about 23 degrees in the soil.
So it's roughly what I have here, but in your notebook you have a chart that looks similar to this, and the reason I'm covering it up is because it has some data on it from a previous experiment. But so down the one column, that is your elapsed time. So we're going to let this sit for 30 minutes, but we're going to come and check it every 3 minutes. We're going to take a reading. We're going to take a reading for the soil temperature, and then we're going to take a reading for the water temperature. And then at the end, we'll have some data so that we can go ahead and we can graph our data, and we can see which one was affected most by the sunlight. And again, we're using our lamp to simulate it, because sometimes Syracuse weather doesn't allow for experimentation outside.
So let the games begin, and we'll be back with the data.
All right. Hi, everybody. Okay, so this is Mrs. Luck here, and I am back to talk about the results from heating earth materials. Okay, so our setup, we had our two earth materials. We had a container of water, we had a container of soil, and we let them sit in the sunlight, or the simulation of the sunlight, under a lamp for 15 minutes. And every 15 minutes, we took a temperature reading, and I recorded it on my graph, or excuse me, on my data table. Then after the 15-minute mark, we shut the light off, and we continue to gather our data for an additional 15 minutes, collecting a temperature reading every 3 minutes for an additional 15 minutes. All right, so what I have here is my data table, and I have it all filled out, and you can see my elapsed time column. I have my soil column, and then my water column. Okay, so by looking at my data, I can see that the soil really heated up much quicker. Okay, so you can see that my starting temperature was approximately 23 degrees Celsius, and then over the course of 15 minutes, the highest temperature that I got was 29 degrees Celsius. Okay, so it rose fairly rapidly. And then when I shut it off, after 15 minutes, it got down to about 25 degrees. Okay, then if I look at my water data, okay, I started at roughly at time 0, it was about 21 degrees, okay, and then as it heated for that 15 minutes, you can see that there really wasn't much of a temperature change. Okay, it was pretty consistent. It held at 23 degrees for a long time, barely just got to about 24 degrees Celsius at that 15-minute mark. And then when the light shut off, okay, or we moved it, quote unquote, into the shade, you can see again that the water was taking was losing energy at a much slower pace compared to the soil. Okay, and then that was my ending temperature, was about 22 degrees. Okay, so I went ahead and I graphed my data. Okay, and there you can see, so the purple line, that was my soil data. Okay, and that you can see that it starts from 0, okay, and it spikes up pretty quickly, and then it cools down, okay, and then you have the blue line for your water data, okay, and it's holding fairly consistently, okay, it's not really changing too much, okay, and what that's telling us is that, so what that's telling us about the effect of sunlight on those earth materials, the geosphere or the soil, and the hydrosphere or the water, is that energy does from the sun transfers to both the geosphere and the hydrosphere, but the effect is different depending on the type of material. So the earth material, the soil, the rocks, they're going to heat up at a much faster rate than water, and then they are going to cool more rapidly. Okay, and then that in turn is going to have an effect on temperature change and then even things like climate. All right, so there was our results for the effect of sunlight on heating earth materials. All right. Hi, everybody. So it's me again. So we just talked about, and I showed you the data, the information that I got from our two different materials, and I showed you that the soil did heated and cooled at a much faster rate than the water. And the reason that this happens, I want to talk to you about that, is that the reason that it was heating up in the first place is because it was underneath the light. Now, for this particular experiment, we used the light bulb to simulate our sunlight, but sunlight really is solar energy, and solar energy travels to the earth in rays or in waves. Okay, and those rays transfer that heat and energy from place to place, and that energy transfer is called radiation. And radiation is one way that energy moves from place to place. Now, solar energy travels through space, okay, goes from the sun and it gets to Earth, and it interacts with the Earth materials. And that energy transfers to the materials, okay, transfers to the materials like the soil, okay, and it heats them up. And that process of that transferring that energy from the sunlight to the earth material, that's called energy transfer, okay? And when solar energy transfers from the soil to water, or transfers from the sun to water, or from the sun to soil, the water and the soil then heat up. Now, this is going to depend the amount of energy or the amount of heat that the materials get depends on a couple of things, and it's called solar energy exposure. And solar energy exposure is the amount of energy that falls on an object. And this depends on two things. It depends on the intensity or the brightness of the sunlight, okay, and the length of time. So if it's around noon when the sun is at its highest, it's going to be very intense or very bright out, and that's going to make the temperature go up. And again, also the length of time. Something that sits out in the sunlight for an hour is going to heat up faster or have a higher temperature than something that sat in the sunlight for maybe only 10 or 15 minutes. Okay. Now, we talked about this. So the earth material, did either earth material, the water or the soil, did either one have or receive more solar energy exposure? And the answer is no. Both of those materials were heated for the same amount of time, for 15 minutes. Okay, so they were heated for the same amount of time, but the soil heated up or was at a higher temperature. So what does that tell us? That the soil received more or it took in more energy, and that it heated up faster. That the soil heated up faster because it was darker. Okay, so it absorbed more energy, which in turn made the temperature go up. All right. Now, I said that this difference of temperature for the soil and the water, that has an effect on things like our weather. Okay, and that is due to uneven heating. Okay, the soil heats up at a much faster rate than water. Okay, so the water heats up and cools off more slowly than land. Okay, and it results in uneven heating. Okay, and that's going to affect our things like weather and climate. Okay, so and the evidence that we have that uneven heating occurs is our data. Okay, so you can see it right here in the data that the soil heated up faster and cooled faster than the water. All right, so that is your evidence. All right, so I hope that this helped you explain the effects of sunlight on earth materials, and you're going to be able to use this information to help you answer the focus question.